Let's start with example 12. Section 4.4. So remember before, we said if we have log any base, let's see the base b, x times y is going to be log to the base b, the x plus log. We have log to the base b divided by y is going to be log to the base b to the x minus log to the base b to the y. And the third one, we have log to the base b, any number with power. Let's take the power here. So it's going to be the power log to the base b. If we have len, the natural log to the x times y is going to be len x plus len y. It's kind of the same thing. So the len is the log to the base e, so kind of using the same rule. So we say, oh, it's different. No, it's exactly the same thing because we already learned that len, the natural log, equal log to the base e. That's it. So you can use the same rule. That means if we have len x divided by y, is going to be len x minus len y. And if we have len x to the power, take the power here, so it's going to be r len x. Is that okay so far? So that's what we're going to do an example. Well, they're telling you solve len x squared y equal what? Multiplication. So it's going to be len to the x squared plus len y. Then I'm going to take the power. Take the power here. So it's going to be 2 len x plus len y. Is that hard? That's example 12. Can we do the same thing with example 13? We have len square root, cubic root of x squared over w plus c. Now, which rule you don't want to use first?
We're going to turn the radical into a.
You can, okay. You said I'm going to turn the radical to rational. So I'm going to say it's len x 2 divided by 3, and here's w plus c.
You're going to put len times x.
That's me. I'm going to use this rule or this rule. Which rule I'm going to start with first? I have a number divided by 2 numbers. I'm going to use the second one. So it's going to be this one equal what? Going to be len x 2/3 minus len what? W plus c. Then the next one.
You're going to put the 2, 3 on the other side of len.
Here, which is move the power here by using the third rule. So it's going to be 2/3 len x minus len w plus c. Can I distribute the len on these two?
Yes.
No. Only if you have what? Multiplication. It's going to be len plus len. If you have addition, you can't do anything. Keep it like this. Is that okay? Number 14, we have log to the base. These two, square root of 4x divided by y z cubed. How are we gonna use the properties to solve this one? What's the first thing you're going to start with? What's that? Can I use the quotient rule? Rule number 2, can I use it? Can you use it or no? If you have quotient between 4x and yz cubed, can I use it?
Yes.
No. But why? Because there is a root. With the rule, we don't have root. So how am I gonna move the root? Exactly what we did here. What you did here on this part, you convert it to rational exponents. Can I do the same thing here? Now, how much the number here? 2, because it's square root. There's no 1. It started from 2. So the square root, this one is 2. The whole thing here, how much the exponent? 1. That means you can write down the whole thing here to the power of 1. So I'm going to say it's log to the base 2, everything here, which is 4x over y z cubed to the power half. Now, is that okay? Yes, I didn't do anything. Now, can I move the exponent half in the front of the log? The whole thing here is exponent. Can I move it here? By using the third rule. We have log to the base 2, 4x divided by yz cubed. Now, is that okay? Now, what's the next step? Which one I'm going to use?
You're gonna the top and then the bottom. You're gonna add the top minus.
Yeah, but before that, yes, you're right. But before that, I'm going. Which one I'm gonna use for the whole thing? The second rule, which is division. So I'm gonna say, be careful. Here is the half. Open bracket, because the half for the whole thing here multiplied by the whole thing here. So it's going to be half out log to the base 2 to the 4x. Okay? Minus log to the base 2 to the y z cubed. Okay? That's why we have to do the division first, then do the multiplication here, because 4 times x, y times z cubed. Okay? That means it's going to be half log base 2 to the 4 plus what? Log to the base 2 to the x. Is that okay? On this part, we did.
Okay, you factor out the log.
Yes, by using the first rule, because 4x, what's that mean? 4 times x. So I can use the first rule. If I have multiplication between two numbers, I'm going to say the first one plus the second one. Log to the first one plus log to the second one. Is that okay? Now here's the minus. Can I do the same thing here? Parentheses, because the minus for everything here. So it's going to be log to the base 2 to the y plus what? Log to the base 2 z cubed.
You factor out the log too?
Log out front.
The log 2, because you're multiplying everything by log 2. You can't factor that out.
Which one? Multiply everything by log 2. Which one are you talking about?
For the x, the y, and the z.
So about multiply this one here.
You could just, because you know how you took the half out, you factored it out.
The half now from everything here.
Okay.
The half, you can keep it outside. If you want to distribute the half, you have to distribute the half for everything. Or you can keep it outside. Okay? The main thing we need to here. Now the negative sign for the whole thing here. Okay? That means it's going to be negative log, negative the second log. Is that okay? So what's gonna happen? I'm keeping the half to the last minute. So I'm gonna say it's log to the base 2 to the 4 plus log to the base 2 to the x. Negative times positive, negative log to the base 2 to the y, negative times positive, negative log to the base 2 to the z cubed. Is that okay? One more thing. You want to distribute the half? It's going to be half here, half, half, half. It's going to be right. One more thing you have to do, and that's it. The power of z cubed, you're going to move it where?
For the log.
In front of this log. Do not move it like someone here. I can move it the whole way. No, this is the power for this log. You got it? So you're going to move it where? Is that okay? And that's it. If you want to distribute the two, the half, it's fine. It's going to be half, half, half. If you want to keep it outside, also it's going to be right. Let's keep working on it. Simplify it. Now, half, before I'm moving it, here's the half, right? Log to the base 2. 4. Can I write it down as a 2 squared? The 4, I can write down 2 squared. Is that okay? Time plus what? Plus half. The second log is log to the base 2 to the x. Keep going. Minus half log to the base 2 to the y, and minus half times 3 over 2 log to the base 2 to the z. Is that okay? Yes or no? Yes or no? That is mistakes. Now, can I move the 2 in the front of the log? So this part is going to be half times 2 log to the base 2 to the 2 plus half log to the base 2 to the x minus half log to the base 2 to the y minus a 3 over 2 log to the base 2 to the z. And what's the next?
You multiply the half and the 2.
By 2 is going to be 1. How much the value of this part?
1.
1. So 1 times 1.
1.
So that's the only thing we do. Minus half log to the base 2 to the y minus 3 over 2 log to the base 2 to the z. That's it. So number 15, it says log to the base 8 4x squared y divided by 3z cubed. Can we do the same thing?
Yes.
Exactly the same thing. So first of all, I'm going to start with the quotient rule, the division. So it's going to be log to the base 8, I'm gonna write down 64 x squared y, and minus log to the base 8 bz to the u cubed. Is that okay? What's the next? I have multiplication. So when I say it's log to the base 8, 64, plus what? Log to the base 8 to the squared, plus log to the base 8 to the y. Okay? For the next part, you have to be careful. The negative sign, parentheses, is going to be log to the base 8 to the 3 plus log to the base 8 z plus log to the base 8 the value cubed. What's the next step?
Break down to 64.
Perfect. I'm gonna write down as a, which is which number?
Squared.
8 squared. That's the main thing. You have to pick a number similar to the base so you can convert it to 1. So I'm gonna say, okay, it's log to the base 8 squared. And next step, I'm going to move the squared here. Can I move the squared? That's 2 log to the base 8 to the x. Here, keep it the same to the base 8 to the y. Minus, I'm going to distribute now the negative sign. Minus log base 8 to the 3 plus log the base 8 to the z minus, this is wrong, minus log base 8 the value cube. Now move the 3 here and move the 2 here. So it's going to be 2 log to the base 8 to the 8 plus 2 log base 8 to the x plus log the base 8 y minus log base 8 to 3 minus log base 8 to the z minus 3 log to the base 8 to the w. Now just convert this one as well. The 1, so 2 times 1 is going to be 2. That means just change this part to the 2 plus the rest. Okay? Number 16. Now we're gonna do the opposite thing. Next example, number 16. We're going to do the opposite thing. We have this part. We have the last step. And we need to go back to the first step. That's what's happening in example 16. What they're telling you, write the logarithm expression in a single logarithm. So you see how many logarithms we have here? So this is a good practice. Like if you want to practice, you're gonna write down the last step and you're trying to go back to the first step. That's what we're gonna do on example 16. Example 16, it says log to the 4x minus 3 minus log x. Can I write down the whole expression to a single log? It's a minus between 2 log. Minus between 2 log. The minus is what? That's it. So it's going to be log this one over this one. Don't flip it. 4x minus 3 divide by x. That's it. We convert the whole expression from two logs in one log. That's it. You don't have to think what's going to happen next. No, don't worry about that. Number 17, is that the same thing? We have log these 2 to the z plus 4 log these 2 to the y. Tell me, how are we going to write down as a single log?
Base 2 zy.
Before that, every number in the front became what? Exponents. So the next step,
Oh, so it's,
log to the base 2 to the z plus log to the base 2 y to the power 4. Okay. Now, if I have a plus between two log, it's going to be what? Multiplication. So z y to the power 4. That's it.
These have the parentheses.
You don't have to write down the parentheses. But I write down the parentheses telling you everything here belongs to the log. Okay? But you don't have to write it down. But you have to write it. But that's a good question. Write it down. If you don't write down parentheses, it's gonna be fine. I'm going to understand it's log for zy cubed, zy to the power 4. But if you have another number here, you have to put the parentheses to tell the reader this is the log only for zy to the power 4. And everything here is outside. For example, log to the base 2 zy to the power 4 plus 6. The 6 does not belong for the log. The 6 by itself. You get the idea what I'm saying? Even if there is a variable here, I'm telling this one is belong to the log, not with the 6. You get the idea? Number 18. Have 3 in x plus ln x minus 2 minus ln 5. How are we going to work on this? What's the best step you want to do? Step by step, don't overthink it. Don't look to the side. Do you have number in front of the ln? The 3, move the 3 here. It's going to be ln x cubed plus ln x minus 2 minus ln 5. Next step, from the left to the right, plus between two ln. There's going to be what? Multiplication. Plus between two ln. So it's going to be ln x cubed times what? We don't have to multiply and distribute and doing anything. Just x cubed times the parentheses. And here is minus ln 5. Next step, if I have negative or minus between two ln, is going to be what? That's be ln x cubed x minus 2 divided by what? That's it. We convert the natural, more than natural log to only one single log. Number 19, put circle on number 20. Solve it and send it to me. Number 19. Have 2 bracket x minus ln squared plus 2/3 ln Z9 minus ln Z. That's cool. How are we going to solve this one? Now again, the 2 is for everything here. So can I distribute it?
Yes.
I'm going to say this is equal to ln x minus 2 ln x squared plus 2/3 ln Z9 minus ln Z. Now tell me what's the next step. Every time when you see number in the front of the link is going to be what? Exponent. So just bring down this, exponent, exponent, exponent.
So the exponent has an exponent?
Which is mean the exponent has an exponent. Just multiply it. 2 times 2 is going to be 4.
Okay.
The exponent has an exponent. That's mean you can combine it. That's fine. The exponent, it's a number with exponents. So 3 squared. That's mean you can write down 3 times 3, which is 9. Is that okay? So it's going to be ln x squared minus ln x to the power. Bring down exponent. What about this part?
It's 9 and 6.
Just mean plus ln z 9 to the power 2/3. Yes or no? Which is equal what?
18/3, which is
18/3, which is
6.
6. That's it. He already said 6. Minus ln z. That means it's ln x squared minus ln x to the power 4 plus ln z to the power 6 minus ln z. Now, what's the next step?
You're going to turn it into a, let me see,
Turn what? I have minus between 2 ln. Here. I have minus between 2 ln, right? So what I'm going to do?
it's going to be a negative ln?
No.
Divide.
We're doing the opposite thing. We need to go to a single ln. That means this one is going to be division, and this one is going to be division, right? That means here is going to be ln x squared over what? Is that okay? What about the next side? Plus, don't forget the plus. Here is going to be what? Ln z to the power 6 divided by z. Is that okay? Yes or no?
Yes.
Simplify this part. X squared divided by x to the power 4. X squared divided by x. So it's going to be 1 divided by ln 1 over x squared plus ln z to the power 6. Cancel 1 z. Yes or no? I have to be careful. Sometimes I do mistakes. Okay. Now I have a plus between 2 ln. It's going to be what? That means going to be ln 1 over x squared times what? Which is equal ln Z5 divided by x squared. That's it. We convert the whole thing to a single log. So with example 21, this is already given.
Yeah.
They give you the amount of log 2, log 3, and log 7 equal these. All right, how are you going to find log 21? Use your brain.
By log 2 by 10 and add
Wait,
out.
wait, wait. No. We're going to use this one. We need to work on this one. Okay? So we're not going to do the opposite thing. Okay? Now, how are we going to find the 21, log to the base b 21 by using these?
Divided by that 7.
No. Do the opposite thing. We're gonna work from this part.
Okay.
We're not gonna. Then we're gonna use what it's given.
You're gonna break it. You're gonna.
How are you gonna break it? Which is give me two numbers. When you multiply it, 3 and 7. Can I say log 21? It's log the base b 3 times 7. Yes. Now with multiplication, by using the properties, it's going to be what? It's log to the base b to the 3 plus what? Log to the base b to the 7.
Yeah.
This one is given, this one is given. I'm just going to say, so it's equal log to the base of 3, 0.6826 plus what? 1.2091. It's going to be equal. Is that okay? The way it's worked, you see, we used one of the properties. I write down 21, break it down as a 3 times 7. Using the property is going to be the first number plus the second number. And it's already given, I'm going to use it. The same thing with the next one. Log to the base b to the 9.
So that would be the answer right there.
No, you're gonna, of course, you're gonna add these together.
Oh, okay, you just add them up.
Yeah.
You add them up and then you just apply that to the log b.
Which one? No. That's it, because log to the base b3 equal. The whole log here equal this number.
Okay, I get it.
And the whole log for the 7 equal this number. I'm just gonna take it and plug in.
Okay.
Don't do anything with the log. Okay? It's already given. The next one, it's log to the base b to the 9. They ask you to find this one. Can we do that here by using? You can't plug it in the calculator. Do you know why? Why we can't plug in this one in the calculator? Because I don't know the base. It's b. I can't plug in this one in the calculator because it's a base b. I can't consider it's 10. You got the idea? That's what's going to be if you're taking chemistry classes or biology, if you're doing biomedical engineering. So now, how I'm going to break down the 9 in a way I can use one of these logs.
3 is 9.
Okay. Okay, let's work on this. He said 3 times 3. Or you can say squared. Both should be give you the same result. So you said 3 times 3, sister right. Log to the base of 3, you can say 3 times 3. Or you can say it's log the base b 3 squared. Sister right. Here, you're going to move the square in the front. Here, you're going to say what? Log to the base 3 plus log to the base b to the 3. Here, 2 log to the base 3, base b to the 3. Is that okay?
Yeah.
So both ways it should be right. Here, you're going to plug in the number 0.6826. You're going to add 0.6826. And here is going to be 2 times 0.6826. 100% the same. So So this is the formula, like I'm telling you, I'm trying to give you all the methods how to deal with the logarithm. So now we're going to use a formula, it's called change of base. You're going to change the base. The formula says every time when you have log to a number with the base, you can bring any base, but then it's going to be log to the number with the log to the base. The base here is not anymore base, okay? The common log, sometimes they use the base 10, which is fine. Or you can say, you can use the natural log. This part is equal what? Ln x over ln b. Both is going to give you the same result. Okay? So if you want to just, okay, if every time I'm telling you use the change of base formula to this number, what I'm telling you, log the base 7 to the 15. If they ask you, use the change of base. Yes, the whole thing you're gonna plug in the calculator is fine. But they ask you to use the change of base formula. Which one? You wanna use this one or this one? Both is gonna, let's do it both. Let's do it both. You can say this one is equal log 15 over log 7. How much the base?
8.
8 is the variable here. Mean any number.
Number.
So if there is no number here, what's that mean?
10.
10. There's no number, 10. So I don't have to write down a base. Keep it as a 10.
Okay.
Because you can choose any base.
You'll be right.
Any base, any number. Okay? Now, but it should be the same. Now, the common log is 10. So you can choose, okay, it's log 15 divide by log 7. That's it. If you want to use the ln, it's the same thing. You can say ln 15 over ln 7. Because the base here is log to the base e, is log to the base e. You get the idea? And then go ahead and plug in everything here, plug in everything here, you're gonna get. You got it? But the main thing, they ask you to use this formula. Like, okay, yes, I can plug in here on the calculator to find, but try to use the formula because that's another way to deal with the log. The next one is, what about this one? Log to the base 5, 0.3. How are you gonna deal with this?
0.3 divided by log 5.
That's it. You can say it's log 0.3 divided by log 5, or you can say it's ln 0.3 divided by ln 5. Both should be right. Okay.